All right, so now we're going to be talking about tangent lines. So the definition of a tangent line, I'll go ahead and type again for us. A tangent line is a line that intersects a circle exactly once. Okay, so only one time. So they're on the outside of our circle, like they are pictured here, but it's only going to touch our circle at one point and one point only. So we're going to call B our point of tangency. And then this is tangent M. Okay. There are two things that happen between circles here. One is internally common tangent lines, so internally means in the middle. So I could draw a line that touches, so I'll need to adjust this some, but that touches each circle just once. It would look like this. So this is tangent to circle A and circle B, and then I could do another one the other direction. So that's what internally common tangent lines would look like. And then there is such a thing as externally common tangent lines, meaning they're on the outside, that would, again, touch each circle just the one time. Let's see if I can adjust that. Really just wants to snap to be horizontal, it looks like. Okay, I think that's as close as I can get it. So it would be touching both circles, and then, again, there could be one on the other side. Just on the outside instead of the inside. All right, our theorem for tangents is if a line is tangent to a given circle, then the tangent line is perpendicular to the radius of that circle at the point of tangency. So if B is my point of tangency, it is perpendicular to our radius that would also connect to that point. And that happens because the radius is going to be our shortest distance to that point, to that tangent, and then that always is going to be perpendicular. So we'll say here, shortest distance from a point to a line is perpendicular. All right, given that line BD is a tangent line to the radius of A, circle A is 5 centimeters. So they've labeled that for us, and BD is 12, and determine ED. So if I want to find the whole hypotenuse here, I know that this radius again would have to be 5. If I want to find the whole hypotenuse, I would do my Pythagorean theorem. 5 squared plus 12 squared equals c squared. And this is going to end up giving us 13. And that's a pretty common Pythagorean triple if you recognized it at the beginning. So if the whole thing is 13, that's going to make our x 8. If we take 13 minus 5, we'll end up with 8 centimeters. All right, number 1, solve for the requested information given that AB is a tangent line to circle M. So we are trying to find AB, it says here. So we know that the hypotenuse is 7 and one of the legs is 4 since my radius is 4. So we would do 4 squared plus B squared equals 7 squared. And it said in 2 decimal places. So then we'd have 33. So square root of 33, 5.74 centimeters. All right, on letter B here, they're saying that this is 4, and they're saying these two are the same as well. So I'm going to have one leg of 4 and one leg of 8, and we're trying to find the hypotenuse. So 4 squared plus 8 squared equals c squared. So that gives us 80. So then we got a square root 80. 8.94 centimeters. All right, and on this one we're looking for AM, and they are saying both legs are 7. So we want the square root of 98, it looks like. 9.90, so, or this one says exact form. So if it's 7 and 7, this would end up being 7 root 2. Because it's a 45, 45, 90, or if you simplify this into 49 and root 2, that's 7 root 2 that way as well. All right, next page. Converse of this theorem, so the opposite. If a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to the circle. So we're saying that if the radius and this line are perpendicular, then that line must be a tangent. So we can check this by doing our Pythagorean theorem converse, which is where we plug in all 3 numbers to our theorem and see if it works. So here we have 3 squared plus 4 squared equals c squared. So 9 plus 16 equals 36, and we end up with 25 does not equal 36. So no, M is not a tangent line. It must cross more than once. All right. Is line M a tangent line to circle A? So again, here we have our perpendicular piece. This section would be 6, so it's going to make my whole hypotenuse 9. So I'll have 6 squared plus 8 squared equals 9 squared. So 36 plus 64 equals 81. 100 does not equal 81, so no, it's not a tangent line. Even though it looks like it crosses once, it must cross twice. Like maybe it crosses again right here, but it can't be a tangent line if that's not perpendicular. All right, this one we have 6, 12, and 13. So 36 plus 144 equals 169. I think that would give us 180 does not equal 169. So again, this would be a no. All no so far. Okay, if 2 segments from the same exterior point are tangent to a circle, then they are congruent to each other. It's kind of like isosceles triangles here. So if B is a point of tangency and C is a point of tangency, but they both connect at point A, then we're saying that these two segments are congruent. So it says here the three segments are tangent at point B, F, and D. If AC is 12, where's AC? So this whole thing is 12. CE is 20. And FE is 13. Determine AF. So I know FE is 13. Straight across here would also have to be 13, which would make this piece 7 to get a total of 20. So this one's 7. So then missing 12 minus 7 would give me 5 here and here. So they want AF. AF is 5 centimeters. All right, last one. The three segments are tangent to circle A at points E, F, and G. If BE is 8, BD is 20, and the perimeter is 50, determine CF. Okay, so this is what we're looking for here. So let's fill in what we know. We know that this would also be an 8 here. This is a 12 and a 12. And then we know that these two would be the same. So let's go ahead and add them all up. We have 8, 8, 12, 12, x, and x equal to 50. So that'll give us 2x plus 40, or 2x equals 10. So x must be 5. So CF is going to be 5 centimeters again. All right, that's it for our notes today.